Hi and welcome to my YouTube channel. Um, Ever since the HDZero goggle and the Watson VRX reached the hands of FPV pilots around the world, I think starting from the end of December, early January, I think it created a lot of buzz in the FPV world. I myself, I received my HDZero goggle together with the 90 FPS camera first week of January. The same week, I also received my Watsnail VRX together with the Avatar HD kit with the micro camera. But due to work, I was not able to install the camera, the VTX on my quad. I never really had a chance to test it out, not until last weekend. Um, uh, Last weekend is like a long holiday over here in Malaysia. It was public holiday on Monday and Tuesday, so I had Saturday, Sunday, Monday, and Tuesday away at my mother-in-law's place, some 120 kilometers north of Kuala Lumpur. So, but all this while, I've been looking at all the YouTube reviews of the HDZero goggle, the new VRX. But in particular, I'm excited about the HDZero goggle. It was something that I've been uh, wanting and decided to buy when the news first came out last year, at the middle of last year. So I remembered when the same thing with the Watsney VRX. I remembered when both those products, I think Watsney was launched or the VRX was open for sale on the 1st of November. Within 10 minutes of the sale being online at Cadex's website, I put in my order. Same goes with the HDZero goggle. I think on the 15th of November, same thing. When HDZero opened up the website to take up the orders, I did it within minutes. So, like I said, I received it back in January, but in all this while, I've been looking at reviews. I know there's a lot of reviews that I've seen. For instance, I think Ian Lewis from MedTech did a very good, comprehensive review of the HDZero goggle. Chris Rosser here, um, you know, he did this test, latency test, and as he said it,
and Nano 90 camera against all the other video systems available in their fastest possible configurations. And HDZero is just faster now than anything else. And the differences are not small either.
So that's what Chris also had to say about the new HDZero 90 FPS camera. So I think last week I finally had the time to finally install the HDZero 90 FPS camera on my 533 light switch, and I brought it along with me for over to my mom's mother-in-law's place over the weekend. Um, I think on Sunday night, I think Johnny Five came out with this particular video where he reviewed his experience flying the 90 IPS camera. And on Monday afternoon, I finally had the chance to fly my 583 light switch with the HD0 90 FPS camera. So, but I did the review in Malay language. I think just like Johnny Five, I was really excited. It was nothing like I've seen before. That experience seeing the FPV feed through my HDZero goggle. And then that afternoon, Joshua Bardwell came out with this.
It's hard to say whether. Wow.
So I think even
Oh yeah, just
this
like that.
video created a lot of buzz. I remember I shared all these videos on some Facebook groups that I have, and one of my friends asked me if I can do a comparison between the HD0 goggle, HD0 90 FPS camera versus the analog. So initially I thought I wanted to reply to him, type my reply in Facebook, but I thought it would be easier for me to just to come up with some video to explain why I think it's really pointless to do a comparison between the HDZero 90 FPS versus analog. And on top of that, I also did another video where I tried to explain why FPV latency, depending on the type of flying that you do, might impact how you fly your quad. So but I did that I would say that video, that explanation, I did it in Malay language. So I thought maybe it's a good idea if I can also do another video, but this time around in English. And when I did my video earlier, I was using my quad as as tools to explain the concept of that latency. But this time around, I think I'm going to do it over a PowerPoint. So let me just switch over to this PowerPoint I prepared earlier. So this is the PowerPoint that I created, trying to help me explain or illustrate the FPV latency concept. So as you can see, I have this set of columns and rows that I created using just tables. The bottom line represents timeline, which starts at 0 milliseconds with 50 milliseconds increment. So it goes from 0, 15, 30, 45, 60, 75, 90 up to 105 milliseconds. And the top line, I have another marker set to represent distance, unit of distance. It could be meters, feet, or whatever. Let's just call it distance 0, D0, 1, 2, 3, 4, 5, 6, 7 to represent distance traveled by the quad. So another thing, we have to assume that all things are equal. We have two quads, identical quads, and we have two identical pilots in terms of reaction times, skills, and whatnot. So the only difference between these two quads and the two pilots is that one is flying the HDZero system and another one, let's assume the Walksnail system in this case. It could also be DJI. So HDZero system is a fixed latency system, and we assume that this quad is using the 90 fps camera running at 540p. Whereas for the Walksnail quad, it has the maybe the standard Walksnail VTX, and it's running at 720p 100 fps. The Walksnail system is a variable latency system, and let's take Chris Ross's latency test as the benchmark. So let's assume that the Walksnail system runs at 30 milliseconds latency. So let's start the scenario. The moment the buzzer goes on and both pilots launch their quads into the air at 100% throttle, let's take that as the starting time at 0 milliseconds. So after 50 milliseconds, the quad will have moved to position D1 in real time. So the spectators here will see that both quads are now at location D1. Whereas for the FPV pilot, for the HDZero, he will see that his quad has just left the starting line. Whereas for the Walksnail pilot, due to the 30 millisecond latency, he will see that his quad is still at the starting line, despite him launching his quad at 100% after he heard the buzzer. So now let's move on to the 30 milliseconds timeline. By this time, both quads are at location D2, For the HDZero pilot, he will see that his quad is now at location D1. Whereas after 30 milliseconds, the walk-snail pilot will only see that his quad leaving the starting line. So you can already see the difference. Now let's move to the 45 milliseconds timeline at this point where both quads are location D3. For HDZero pilot, he will see that his quad at location D2, whereas for the walk snail, he will see that his quad is at location D1 through his goggles. So now let's move to the 60 millisecond timeline, 60 milliseconds after launch. Alright, so, and let's assume another scenario. At the time of 60 milliseconds, let's assume a wall or some obstacle just pops up at location D6. Okay, so at 60 milliseconds, a wall appears at location D6. At this time, the HDZero pilot will have reached location D3, whereas for the walk-snail pilot, he will be at location D2. But we have to remember, at the 60 millisecond timeline, where the wall appears, both these pilots will have not seen the wall yet in their FPV goggles because of the FPV latency. So only after another 50 milliseconds, meaning once both quads have reached location D5, at this point of time, the HDZero pilot will be at location D4, 50 milliseconds after the wall appeared, and that's when he will see the wall appear in his FPV goggle. By which at that point of time we assume that the HDZero goggle will then make the evasive maneuver, try to avoid the wall, maybe fly over it. He will then react by sending the command to his remote controller so that his quad will move away from the wall. Whereas for the walk snail pilot, at this point of time, we'll see that his quad is at location D3. But unlike the HDZero pilot, 50 milliseconds has elapsed since the wall appeared. It's not even 30 milliseconds yet. So at this point of time, he will still not see the wall appear in his FPV goggles. So by the time we reach the 90 milliseconds timeline, by which both quads will have reached location D6 where the wall is, like I said, the HDZero pilot at this point of time will have sent his, maneuver his quad, send his signal to his remote to make his quad move away. And by this point of time, he will see that his quad should be starting to move away from the wall if he is fast enough to react to the wall appearing in his goggle. Whereas for the walk snail pilot, at the 90 millisecond mark, he will only at that point in time he will see the wall appear in his goggle. At that time, his quad in real time will have reached the wall. So he will not have enough time, or even when he sees the wall and send command to his remote to take evasive maneuvers, it will be too late because his quad will already be on at the wall. So this is where the difference is, and I hope this will illustrate why in certain instances this latency ability does make a difference. Okay, now if we go back again, there's another big factor that we have to take into consideration. Like I said, HDZero system and analog are fixed latency systems, so the latency remains the same throughout the flight. So it's going to be 50 milliseconds all the time. But for systems like walk-snail and DJI, they are variable latencies. So while their average or fastest latency could be 30 milliseconds, but it could change. It can go higher depending on the many factors. It could be RF interference and whatnot. So let's just assume the same scenario like we did earlier, but this time around, let's assume that after both quads leaves the starting line, the walk-snail pilot FPV feed latency goes up to 60 milliseconds. So what happens is that after 60 milliseconds, the quad will be at location D4, by which the wall will suddenly appear. The HDZero pilot will see his drone or quad at location D3 because he's 50 milliseconds behind real time. Whereas for the walk-snail pilot, assuming that, like I say, for whatever reasons, his latency at that point of time is 60 milliseconds, then even though his quad is at location D4, in his FPV goggle, his quad is just starting to leave the starting line. So this will make it even harder for the FPV pilot to avoid that wall. So, and to make things even worse, when you have variable latencies where latency moves between 30 to 40, goes back to 30 and then goes back to 60, then it will make it even more difficult for the pilot to have this sense of where their quad is really located in real time in the air, and and their response time to their remote control. So that'd be different comparatively to a pilot who flies HDZero or analog because of the fixed latency. So I hope this explanation, this illustration that I did just now, can help you understand the concept of FPV latency. Again, for me, the latency is a different thing compared to the FPV frame rate. So that's a different thing altogether. Um, so I think that's all. If there's some mistake, or if you believe there's something wrong with how I explain the scenario, do let me know. Just put up your comments in the YouTube comment section. I would love to hear your comments. And yeah, until we see next session. Bye.